Seatbelts, everyone! Please let this be a normal field trip. With a friend? No way!
Cruising on down Main Street, you're relaxed and feeling good. Step inside, it's a wild ride. Come on, ride on the magic school bus.
Hi kids, today we're going to be learning about gases. To start out, I'm going to explain what a gas is. A gas is a phase, a state of matter. It has perfect mobility in which atoms move around freely. And today we're going to be going to a museum to see statues of actual chemists. Let's go. Yay! Come on kids, let's go into the magic school bus.
So before we leave, kids, do you guys know what temperature is?
I do. The average measure of kinetic energy.
Well, what's kinetic energy? Motion? Good job, guys. Now do you know what the definition of pressure is?
Pressure is when your friends try to make you do bad things.
Not exactly. When dealing with gases, pressure is a force applied on an area.
Is this pressure?
Yes, but no shoving. Oh look, we're here. See all the statues of the chemists?
Whoa, did we just travel back in time?
I guess so. Let's go down and meet them. Look at this average water bottle. See this? It's constant because it's not being heated or cooled. So if I squeeze this water bottle, I'm putting more pressure on it, right?
Yeah!
And when I put more pressure on it, it gets smaller, so the volume decreases.
But why does the volume decrease?
The gas particles are forced closer together. When we add more pressure, the volume goes down. So that means if we add more volume, the pressure goes down.
Oh!
The word to describe the relationship between pressure and volume is inversely proportional. This is the equation to find the first or final pressure and volume.
So, if I blow up the balloon, I'm adding more moles of air into the balloon, meaning there'd be a greater volume, right?
Yeah. What conditions does it occur at?
It can occur at any condition, but at standard temperature and pressure, it's 273 Kelvin, 1.008 atmospheric, and 1 mole equals 22.4 liters.
Look at this balloon. I'm not putting any pressure on it. Well, if I put it in the freezer, it'll get smaller. It'll get smaller because it'll lose kinetic energy, or temperature, meaning that it won't have enough energy to move around and push the sides of the balloon out.
So if we lessen the temperature, the volume will lessen too?
Yes, that means the temperature and volume are proportionally related too. This is the equation we use to find the first and final temperature and volume of a certain gas experiment. See? Look how much the balloon shrunk.
So I put a set volume of water into this kettle. Now look what happens when I heat it up. As the steam gets hotter, the pressure of it increases and it has to escape through this little hole or fuse out of the kettle.
But what does the pressure of the steam mean?
The pressure of the gas molecule is increasing. When the temperature increases, the molecules bump into each other more, so the pressure increases. So that's why when it's heated, the steam has to escape. So temperature and pressure are directly proportional. This is the equation for it. But where's Dalton?
It appears that Dalton is in here, but I will explain his law. We use his law to find the partial pressures of a mixture of different gases. According to Dalton, the sum of the partial pressures equals the total pressure of the entire mixture. Oh golly gee, I forgot something else too! Kids, what do we do if we want to combine Boyle's, Gay-Lussac's, and Charles' law?
The combined gas law!
Yeah, the combined gas laws are all the laws put together, and it's used to find the change in temperature, pressure, and volume. And this is the equation we use. Good job, guys. Let's get back on the bus. So, did you guys have fun?
Yeah, but Miss Frizzle, according to my research, there's one more law, the ideal gas law. Can you explain it?
Oh, I almost forgot. We use the ideal gas law when there's no change in temperature, pressure, or volume. And it is PV equals nRT. Okay, let's go back to school now.